The last conic section we're going to look at is a hyperbola. This definition is exactly the same as the definition for an ellipse, except for one word. Does anybody see the one word that is different here than with an ellipse? Yeah?
The difference?
The difference. So instead of measuring the distance between 2 points, adding those two distances together and getting a constant, you're going to measure the distance to 2 points and subtract them and get a constant. Okay, so I'm going to show you kind of what that looks like a little more interactively, and then we're going to go through all the vocabulary for hyperbolas. Some of it's similar to an ellipse, some of it is different. Okay. So that's what a hyperbola looks like. There's two pieces, which I'll tell you the real name in a little bit. But points C and B are imaginary points that each part of the hyperbola bends around. I'm going to take point E, and I'm going to drag it either along the left part, or I can move it over to the right part. As I do that, I'm going to measure those two distances, line segment EC and line segment EB. Okay, that's the distance from that point straight to the first focus and to the second focus. As I move it, the two boxes in pink are going to change, but the difference between the two is always going to be 5.66. Well, the absolute value of the difference. Okay. So put this over here. I don't want to move that. Just that. Okay, so as I'm moving those two numbers, if you took 2.46 and you 8.12 and subtracted 2.46, you would get 5.66. That's what it would come out to. No matter where you put that, difference between those two numbers is 5.66. Okay, and if I move it over to the other side, check it. Take 11.55 and subtract 5.89, and you get 5.66. So the difference is always 5.66. On any hyperbola, it doesn't always have to be 5.66. It has to be the same number for a certain hyperbola. For this one, it's 5.66. All right. So any question on that? You're measuring the distance to two fixed points and subtracting, and it always comes out the same. So those two fixed points, those are called the foci. Just like on ellipse, we have two of them. The line drawn through the foci, that is called the transverse axis. And that's replacing the major axis. That horizontal line I just drew, transverse axis. If you draw in, let's say here's your two foci. If you draw in a line segment and find the midpoint of that line segment, what do you think the name of that point is called? The midpoint of the line segment that connects the foci. Yeah.
Center.
Yep, that's called the center. And I think that's the same definition we had for an ellipse. It's the midpoint of the line segment connecting the foci. Now, if you draw a line through the center and perpendicular to the transverse axis, this is what we call the minor axis yesterday. Right. Today, it's called the conjugate axis. So that's a line through the center, perpendicular to the major axis. Now, like ellipses, there are only going to be two cases. Either your transverse axis is horizontal, or your transverse axis is vertical. We won't be drawing a hyperbola on an angle. You can, but we're not. The two pieces, and this is the only conic section that when you draw it, it is two separate pieces that don't touch. The pieces are called the branches. So your branches either open up and down, or they open left and right. So those are your two cases. If you draw the transverse axis and look where it crosses the hyperbola, that point and that point, or that point and that point, those are called your vertices. So like an ellipse, the vertices are an actual point on the shape. The foci are not. The foci are an imaginary point. And there's one other thing that's going to be going on here that we need to talk about. And we will get to this, but it has something like that and something like that. What do you think those two lines are that I just drew? Yeah? No, not a hypotenuse. Yeah, they are asymptotes. So as we draw, it's not a great picture, but when you draw, it's going to be an asymptote that the branch gets closer and closer to. But if you can find those asymptotes, it's going to help you to make a very good sketch.
I don't know why I said that.
Yeah, well, that's okay. That's why you're here and not right here. Because I'm showing you how to do it. So ellipses don't have asymptotes, parabolas don't have asymptotes, circles don't. This is the only conic section that does. So the nice thing is to find the asymptotes, you still use the same letters, the A, the B, and the C. You just have to know how to use them to get the equations of your asymptotes. All right. So we're going to look at the case, first of all, where the hyperbola has not been shifted. So for now, you don't have to worry about H and K. A and C are exactly the same thing as yesterday. A is the distance between the center and the vertex. C is the distance between the center and the focus. B doesn't really have a visual that I can connect it to that I know of. It's going to be used when we talk about the asymptotes. Let's look at our equation, and I just want you to tell me what looks different about that equation than the one we had for an ellipse. Yep.
The symbols are different between the two equations. So like the first one, that's negative instead of positive, and then that's addition instead of subtraction.
Yeah. So when you are writing the equation of an ellipse, you have two fractions and you're adding them. When you're doing a hyperbola, you have the two fractions, but you are subtracting them. Still equal to 1. As we saw with an ellipse, it doesn't have to equal 1, and it's still an ellipse. But the standard format is to make it equal to 1. Now, there are two different versions of the hyperbola. One of them has the transverse axis horizontal. The other one has the transverse axis vertical. The transverse axis is the one that cuts across the branches. It connects them. Think of transverse, kind of looks like the word traverse. And if you traverse something, it means to go across it. Right? And that's what this does. It goes across the branches. Now, the way you can tell whether the transverse axis is horizontal or vertical is by the letter that's right there. When you write the equation of a hyperbola, One of your letters has a negative in front of it, the other one is positive. Whatever letter is positive, that is the direction of the transverse axis. So in this case, the x is positive, the transverse axis will follow the x. So what's going to change places in this one are the two things I just circled. The A and the B do not change places. It's very different than an ellipse. A is always first, B will always be second. That will not change. A first, B second. It's the x and the y that can change places. And usually when you're trying to find the equation or you're trying to discuss it, you need to find something about the vertices, the foci, and a lot of times you're going to need the b as well. This is the connection between a, b, and c. It's c squared equals a squared plus b squared. Yesterday it was minus b squared. So again, just a little difference, but we got to keep track of that when we do hyperbolas. And now, if that was an ellipse, we'd be done. Okay, that's all you need to know. There's one more thing I need to tell you about hyperbolas. What is the equation of the asymptotes? To find the asymptotes, you do not have to do any additional work. You use the information you already have. When your ellipse is at the center, the asymptote goes through the origin. So there's no y-intercept. The y-intercept is 0. The way I remember it is when it's horizontal, the slope is b over a, HBA. When it's horizontal, the slope is going to be b over a. That one doesn't sound as good, but when it's vertical, it's going to be a over b. So that's actually the one I remember. VAB. I remember VAB. Vertical, transverse axis. The asymptote has a slope of a over b. And then the other one is flipped. Horizontal is b over a. Okay, we're doing horizontal right now. All right, so now when you discuss a hyperbola, that's the one extra thing I want you to tell me. I still want to know the center, vertices, foci, direction of the transverse axis, but I also want to know the equation of the asymptotes. Okay, so if you are trying to graph a hyperbola, I would say you probably need about 3 points on each branch. So if you had a point like this and like this, that'd give you a pretty good picture of the left. And then 3 points on the right branch. A lot of times I'll do the points that are above and below, like if your focus was right here. I'll try to find the point that's up here and down there. You don't have to, but if you're going to draw it, you need about 6 points altogether. So A and C, I've already explained to you what those were. I did put an absolute value around A because I don't want you to think, even though there's a negative here, I don't want you to think of A or B as ever being a negative. And you know what? I don't think I ever give you one where A is a negative. If I did, well, you'd have to rewrite it so the negative is in the middle. That's where the negative has to be. It can't be on the A and it can't be on the B. You'd have to swap your fractions and put the negative in the middle. But I don't think you're gonna have to worry about that. Okay, so A is center to vertex, C, center to focus. And that's over on the side as well. All right, so let's try some examples. So the first one, we'll find the equation, and I will graph it. Okay, so we've got our center, our focus, and our vertex. That is enough information to find the A and the C right away. What is A? Yeah. A is the distance between the center and the vertex, and that, in this case, that is 2. B, we don't have enough information to find. We're going to come back to that. But how about C? Let's see. Yep. C is the distance between the center and the focus.
Oh, I was thinking the focus of the vertex, that'd be
3. So C is 3. Now we can't write the equation without B. What's the formula that connects A, B, and C for a hyperbola? Yep.
C squared equals A squared plus B squared.
So C squared equals A squared plus B squared. So we're going to get B squared is 5, which means B is the square root of 5. Again, what do you really need in the formula? You need B squared to write the equation. But I wrote down B. Okay, asymptotes. When your transverse axis is horizontal, which this one is, because if you graph these 3 points, 0, 0, 3, 0, negative 2, 0. 0, 0, 3, 0, negative 2, 0. They'll line up horizontal. When you're horizontal, the equation of your asymptote has a slope of B over A. Positive or negative. So y equals positive or negative B over A. Those are your asymptotes. And, oops. Yeah. Okay, so we'll use the asymptotes in a little bit. We'll come back to them. But now I want to write the equation. All right, transverse axis is horizontal. That means make the x positive, make the y negative. So follow this pattern. So x squared minus y squared goes in the top. That's equal to 1. Yeah?
Got the x on the asymptote equation.
Oh, I thought I had that. Nope, guess not. Thank you. Denominators. First denominator is a squared. Second one is b squared. Don't ever change that for a hyperbola. So a squared, b squared. And that is the equation of your hyperbola. Great. Any question how we got the equation? It's not hard, but there are a lot of things to remember. Little things. All right. Now, square root of 5, that's not really a nice number if you're trying to graph using rise over run. So square root of 5 is about, we'll call it a little more than 2. So we go a little more than 2 up, and then 2 to the right. And that is what I did right here. I went a little more than 2 units up, and then I went 2 to the right, and then I went a little bit more than 2 units up and 2 to the right. And then I did the same thing going down. A little more than 2 units down, right 2. A little more than 2 units down, right 2. What that X shape gives me is kind of the boundary of where my branches are going to go. The branches are always going to be across from each other vertically in that X shape. In this case, are they going to be across from each other horizontally or vertically? Which way? Yeah? Yeah. Right. We already answered the question, which way does this go? The transverse axis is horizontal. That's what the blue dots are. So to graph it, what I would do is plot both of your vertices, but they only gave me one of them. -2, 0, Where's the other vertex? Yep. Positive 2, 0. Okay, so let's plot just those. Don't plot the foci. So negative 2, 0, positive 2, 0. And really you don't even need another point. If you put your asymptotes, you can get a pretty good sketch with just that. Okay, so just stay very close to the dotted line, and then start to curve away from it, and then start to get closer and closer. Right. Same thing over here. Come down, kind of curve through the vertex, and then get closer and closer. And that's what that hyperbola would look like. All right, any questions on that? If you were to sketch it on the calculator, the way the calculator would do it is it would sketch that part and then that part as the same graph. And then it would do this part and that part as the same graph. So we do the two green together and then the two blue together, because it can't draw something that fails the vertical line test all in one piece. All right, so that's being given some information, coming up with an equation. Let's switch it, and now I'll give you the equation and see if you can tell me all the info. Okay. First thing we want to do is figure out the A, the B, and the C. Can anybody tell me any of those three letters, which one they think they know? Yep.
Would A be 4?
A would be 4. Why? Because there's a 4 right there?
Because the square root of 16 is 4.
Right, just a coincidence there. It's the square root of the first number. That's A. How about B? Yep. 2. Square root of the second number. Now, if they don't ask about the foci, then don't worry about C. But they do, so you need C. What's the formula to get C? As long as you know A and B. Yeah.
The c squared equals a squared minus b squared.
So C squared equals A squared plus B squared. So that means C squared is 20. Square root of 20. It's 2 root 5. Okay. Let's start. I always start with finding the center and the transverse axis. Those are the two things you should do first. What is going to be the center of that ellipse? Yeah?
0, 0.
Yep. You're going to know when it's not 0, 0, because you're going to start to have, I don't know if I have one already done. Well, you're going to have one where you have a plus or a minus in the top. That's going to shift it. If you don't have a plus or a minus with the x and the y, center is 0, 0. Okay. Which way does the transverse axis go? Besides the fact I've only shown you one way that it can go up to this point. How do you look at that and figure out which way it goes? Yep.
Which number has the large one below it? Or which number is bigger? What was it? For example, it's underneath x. Right now, so it's x.
No, it's not which number is bigger. That's for an ellipse. Yeah, it doesn't. If I switch the 16 and the 4, it would have no effect on the transverse axis. It would have no effect on the direction of it. Yeah?
Horizontal.
How come?
Because x squared is positive.
Right. You look for the letter that is positive. One's positive, one's negative. The positive letter is the direction of the transverse axis. It's a little different than an ellipse. But that's why it's horizontal. Okay. Now we can do the vertice and the foci. How many units away from the center are the two vertices? Yeah.
4.
4 units, and they are going to be 4 units to the what and to the what?
Left and right.
To the left and to the right. So we're going to have negative 4, 0, positive 4, 0. When the center is at 0, 0, you can use this symbol right there. When it's not, you can't do that. Okay, foci. How many units away from the center are the foci? Yeah.
2
2 root
root 5.
5, again, left and right of the center. And now we need the horizontal asymptotes. When it goes through the origin, I'm sorry, when the center is at the origin, you don't have to worry about a y-intercept. When it's shifted, you do. Okay, so the equation gets a little more complicated for the asymptote. This is just going to be y equals slope with x. When you are horizontal, what's the formula for your slope? Yep.
B over A.
It's b over a, HBA, b over a. B is 2, a is 4. You can reduce that. Okay, so it's 1/2. Positive or negative. All right. So that's everything that you'd have to describe about your hyperbola. Any question on that one? Okay. So let's try this one. Same directions. Discuss again. All 5 things I want to know. But that's not ready to discuss. What's wrong with that? Yeah. Right. To do all the stuff that I've taught you so far, if it's not equal to 1, then nothing I showed you works. So you've got to make it equal to 1 first. How are you going to get that equal to 1? Yep. By. We do want to divide by a number, but you've got to divide by something that makes this a 1.
Yeah,
36, yeah. And not always, but a lot of times the numerators will cancel into the denominator, so you'll get a nice answer. So your new equation is x squared over 4 minus y squared over 9 equals 1. Okay, that's what you want to work with. All right. What is A? Yep. 2, square root of the first number. Okay, what's B? Yep.
3.
Square root of the second number. A does not have to be bigger than B. With an ellipse, yep, it did. Not with a hyperbola. And C? So C is going to be a squared plus b squared. C squared is a squared plus b squared, which means C is the square root of 13. Okay, so now we got that. Let's go through all the stuff. Okay, 1, 2. Always do those 2 first. Okay, what is your center in this case? Yeah.
0, 0.
Center is 0, 0. Which way does the transverse axis go? Yeah.
Horizontal.
Horizontal, because x is the positive letter. Okay. Parentheses. What are going to be the equations of the vertices? Equations of the 2 vertices. Yep.
Plus or minus 4, 0.
I like the plus or minus as the first number.
Oh, plus or minus 2.
Plus or minus 2. 0. And what about the equations of the foci? Yep.
Plus or minus root 13.
Plus or minus root 13, 0. And the asymptotes? slope, what's the slope when we're horizontal? Yeah.
Is B over A?
B over A, 3 over 2. Positive or negative, because there are two asymptotes. Okay. I don't care the order. After you do the center and the transverse axis, you can do anything else in any order you want. But without these two, you can't really figure out the vertices and the foci. I guess you could do the asymptotes. That's separate. Okay, any question on that one? All right, so now let's look at the equation where everything is above and below. The vertices are A units above and below the center. The foci are C units above and below. So A and C still have the same meaning. For now, center is still 0, 0, but the transverse axis is vertical. And the difference, the A and the B are in the same spot. It's the X and the Y that switched. X now has the negative in front of it. Y is the positive. The positive letter is the direction of the transverse axis. And C squared still equals A squared plus B squared. Asymptotes, it's Y equals A over B for the slope. So again, I remember it as VAB, right? Vertical, it's A over B. That's really the only new thing that you didn't have to think about with ellipse. All right, let's try this one. We've done a lot of discuss. I want to have another equation. Okay, we do. All right, first thing that I need to do to this one to get it ready to discuss. What's the first thing? Yep.
Divide everything by 4.
Divide everything by 4. That's going to give me y squared over 4 minus x squared. You still want to leave it as a fraction because you want to think of it as you need the denominator. So x squared over 1 equals 1. Okay. So there is your new equation. All right, what's A in this case? Yep. 2. And B? Yep. 1. Root 1 is, yep, just 1. And C squared equals A squared plus B squared. What's the square root of 2 squared plus 1 squared? Yep.
Root 3.
Remember, we're adding them up.
Oh, I forgot that maybe it equals to 5
Root 5. Yep. So after a while, finding the C is pretty quick once you have the A and the B. Okay, that's all we need. Okay, where is my center? For now. Yep. 0, 0. Transverse axis is going to go in which direction? Yep. Vertical, because the y is the positive. Now that tells you everything is above and below the center. So what would be your coordinates of your vertices? Yeah.
0 plus or minus 2.
Yep, up 2 and down 2 from the center. Notice I don't say from the origin, I say from the center, because the center isn't always the origin, which we'll see. How about the coordinates for the foci? Yeah.
Could be 0, plus minus 1.
0, comma, it is a plus or minus. And what letter tells you about the foci?
B. C.
No, C. So 0 plus or minus
Oh, square root of 5.
square root of 5. Okay, and the last thing is your asymptote. When you are vertical, what's your slope? Yep. A over B. 2 over 1, you can write that as just 2. So y equals 2x. All right. Any question on describing that hyperbola? All right, let's do finding an equation, and then we'll do shifting. I'll probably skip that one because we've done so many of the discussed ones. We'll do the shifting. Okay, so now find an equation. There's your vertex, your focus, and your center. What are the 3 letters that you want to identify first? Yep.
A, B, and C.
A, B, and C. Doesn't matter what kind of problem you're doing. You always want to figure those out first. Okay. What is A in this case? Yeah, John. 2. It's the distance between the center and the vertex. What other letter can we find pretty directly from those coordinates? Yep. C. C is center to focus. What's the distance between the center and either focus? It doesn't matter. Yep. 3. But to write the equation, you do need B. So C squared equals A squared plus B squared. So we got C squared, that's 9. A squared is 4. So B is going to be the square root of, yep, 5. Again, we don't really need B in this case because they're not asking you for the equation of the asymptote. So you're not going to need B. You're going to need B squared. Okay, I need to figure out which letter is positive. But for now, I know this is A squared, and I know this is B squared, and I know it's equal to what number? Yep, 1. What I don't know yet is what letter goes where. Is it XY or YX? Look at the vertex, the focus, and the center. If you graph those points, do they line up horizontally or do they line up vertically? How do they line up? They line up vertically. Right? This one is up 2, down 3, up 3, and then the origin. That's vertical points. If you want your transverse axis to be vertical, you want the y to be what? Positive or negative?
Positive.
Positive, so put it in front. And then whatever letter you didn't use, that one is negative. And that is the equation of the hyperbola. No asymptotes because they didn't ask for it. Okay, any question on that? So let's finish up with a shift. Now, the book gives you all these fancy formulas to try to figure out like the foci and the vertices and the asymptotes, and okay, gives you all kinds of stuff. Okay. The only thing that I worry about is that I don't care about any of that other stuff. This is just what I told you rearranged. I say C squared equals A squared plus B squared. They wrote it in a different order. This I can figure out automatically as long as I know which way the transverse axis goes. Is it A units up and A units down? Is it A units left or is it A units right? Left and right, up and down. Same with the focus. Is it left and right or is it up and down? Okay, we can figure that out ourselves. And this, all of this stuff, that's just point slope form for the equation of a line. Okay? As long as I know the slopes, B over A and A over B, I can use point slope form and I don't really have to memorize all of that. the point that you're going to use is the center. That's why it's an h and a k in the formula. That's the coordinate you're going to plug into point slope form. Remember, point slope form is y minus y1 equals m times x minus x1. That's all that is. That's your y1. That's a x1. That's your y1. That's all. All right. So as long as you know this box, you're good. We can figure out everything else. So the h and the k, those are the coordinates of the center. The h is always with the x, and the k is always with the y. You never change that. All right, let's try an example. So find the equation. How many letters do we have to figure out now in order to be able to discuss it or find the equation? You need to know 5 letters. H, K, A, B, C. Are there any of those letters that we can find easily from the information that's given? I'd like to do those first if we can. Yeah.
Find H and K.
Yeah, we can get H and K. What's H?
1.
1 and K?
2.
Negative 2. H and K are the coordinates of the center. Those are the easiest two to find.
You can also find A and C.
Yeah, we can now find A and C. Bless you. A little more work to find A and C, but still not that bad. A is the distance between the center and the vertex. What's the distance between the center and the vertex? Right 1 down 2, right 3 down 2. How far apart? Yeah? 2 units. And C is the distance between the center and the focus. How far apart is the center and the focus? Yep. 3 units. Unfortunately, you do need B. You can't write the equation without B. So C squared equals A squared plus B squared. Okay, so I've written it out. C squared equals A squared plus B squared. Solve for B, and you will get how much? Yeah. Square root 5. And is it B you really need? No, it's B squared, because you're going to square that in the next step. All right, so we're going to have 2 fractions. What symbol is going to go between the 2 fractions? Yeah, going to put a minus. What's this going to be equal to? Yeah, 1. I haven't even thought about the transverse axis yet. I don't need to. Yet. What's going to go in the denominator, in the first denominator? Yep. A squared, which would be 4. And what's going to go in the denominator of the second fraction? Yep.
5.
B squared, which is 5. Okay, so now we've got everything that we can do without thinking about the transverse axis. Well, I guess I could do this. Okay. If you graph all those points, they all have the same y value. So think about how they would look. If a bunch of points have the same height, would they line up horizontally or would they line up vertically? Yep.
Horizontally.
It would line up horizontally. They're all at -2. They're just different amounts left and right. So they all line up horizontally. That means we want which letter to be positive. We want this to go horizontal, the transverse axis. We want x positive, we want y negative. Now, it's always x minus, what letter goes with x? Yep, always x minus h. So it's x minus 1. And the other one, it's y minus k. What happens when you do y minus k? Yeah,
You get positive 2.
you get positive 2. So that's the equation of the hyperbola that fits that information. Okay, any question on that? Then if I gave you this, and I said to work backwards and tell me all of that, the first thing you do is identify the h. You'd have to be careful with the k. Some people write k as plus 2. No, k is really minus 2. So you the h, the k, and then take the square root of that, you get a, and take the square root of the second denominator and you get b. And then once you have h, k, b, c, you can figure out anything you want. We did a lot of discussed problems today. All right, so any questions on hyperbolas? And that's it for the conic sections that we're going to study. So tomorrow we're going to do 10.1, okay, and that's on solving systems of equations. So very, very different. Okay. So 13 to 16, that's the matching. That's always the first part. 17 to 21, that's okay. 29, 31, that's fine. And then 53 and 55, we're going to skip those two. Okay, so it's 13 to 16 all, and then everything else is odd. 17 to 21, 29, 31, and 37 through 41. As far as extra help, I will be after school tomorrow. So my extra help will be on Wednesday, because our test is Thursday.